Okay, so we're talking today about rational and irrational numbers. We're on page 2 now. And like I asked you before, I hope you remember at least hearing those terms. We're going to start off the first part of the class talking about rational numbers, and that's going to help us to understand what irrational numbers are. So let's start off with the definition. A rational number is a number, and I'm going to emphasize some parts so that you can really nail this down, is a number that can be written in the form, and then I write A over B. Yes, sir.
Can you slow down a bit?
Yeah, and I'll leave this up for a while. Yeah, I won't rush through it for you guys. So in the form A over B. Now, A over B, what kind of number does that look like? A over B.
A fraction.
It's a fraction. So it can be written as a fraction, but it has to be specific where A and B, so the numbers A and B, whatever those numbers are integers. Oh man, I've heard of that word, but I don't really remember it. That might be the case for you, but maybe for others you do remember what an integer is. So A and B are both integers, and B does not equal 0. How many of you kind of remember that definition? Like, maybe it's somewhere there and it's like, oh yeah, kind of vague but foggy. Now it's getting clearer. Okay, good. Make sure you have this definition down. Our lesson is going to really depend on this definition. I'm going to keep going back to it. You notice I highlight or I underline something, right? Can be. Does that mean it is written as a fraction? No, it can be written. That's a critical part. And then A and B have to be a certain type of number. What type of numbers do they have to be? Integers. And we'll talk about those in just a minute. And B, what does that little symbol mean?
Not equal.
Not equal to 0. Cannot be 0. This denominator just cannot be 0. It makes it a different type of number. Okay, so that definition may be pretty clear, but I'm going to hopefully clarify it by giving you some examples. Everyone good so far? I can give you my notes. Take as many as you can because that'll help you to remember it, but if you miss something, I have them. They're right here. Okay, the first type of rational number, integers. Whoa, we already talked about those kind of. Does anyone remember what an integer is? What's an integer? What type of number? Now I'm going to give you a little hint. On page 2, there are highlighted terms. You can see the yellow terms that are highlighted, but there are also italicized terms. Both of those are going to be important. So I don't mind if you look, as long as you look correctly and you tell me. Let's go to Nick.
Says which are whole numbers and their opposites.
Yep, whole numbers and their opposites. Whole numbers and their opposites. You're like, what? What are whole numbers? Okay, another helpful tool in your book is, for example, underneath that picture on the first page there, you see this yellow box. You're like, that's a whole number. Can anyone tell me what a whole number is? Yep.
1, 2, 3, or 4.
Okay, 1, 2, 3, 4. What else? What other numbers included? 0. 1, 2, 3, 4, 5. You see that in that yellow box? It says 0, 1, 2, 3, 4, 5, 6, 7. So it's all those numbers and their opposites. So -1, -2, -3, and this is how we display them normally if we're trying to write a set. You put your 3 dots, and this is not the only way, but this is one way to do it. Dot, 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 with these braces here. What do the dot, dot, dots or the ellipses mean? What does that stand for? Dot. Yep, why? It goes on forever, not only to the right, 3, 4, 5, 6, 7, 8, infinitely, but it also goes on to the left. It gets smaller and smaller and smaller, -4, -5, -6. So This set of numbers is infinite in both directions. These are the integers, which these are, I think, the most liked numbers because you use positive, negative, and they're very straightforward. But those aren't the only types of rational numbers. The second type, and you know what I did in my notes? I actually gave you a definition for this, but I don't think you need it. Fractions. Fractions, or a fraction. A fraction has a numerator and denominator. Sorry, let me correct this here. A fraction has a numerator. You don't have to write that down. Can you guys identify a fraction? If I showed you one, you're like, that's a fraction. Okay. A third type is going to be a mixed number. I also wrote a definition, but I'm like, I think they get this. Can somebody tell me what a mixed number is? So I know what a fraction is. What's a mixed number, Marissa?
It has like a whole number and a fraction.
Whole number and a fractional part. So it has two parts. That's a mixed number. I hope you understand that. If you don't, there are examples in your book. So it's not like it's totally nebulous or vague. All right, those are the first three types, but there is a fourth. And this is where the lesson really is emphasized. The fourth number, anyone know? Oh, wait. I was reading your about me's, and a lot of you put, I don't understand fractions and decimals. How many of you maybe wish decimals and fractions weren't even there? Like, that would be so much easier for life? Yeah, I think they make it easier if they weren't there. So when we talk about decimals, we're actually talking about what most numbers are. I wish all the numbers were integers, but they're really not. I mean, from money to groupings to averages they're not going to be whole numbers or integers. They're going to be fractions and decimals. So that's why we want to talk about them, because we want you to be able to deal with them well. There are two types of decimals. Terminating. Does anyone know how you can maybe define terminating decimals? What does that mean? Jensen?
It ends.
They end. Decimals that end. So examples of terminating decimals would be 41 hundredths or 0.41. 3 is also a terminating decimal. Wait, did I write that? Is 3 a terminating decimal? Yeah, you could say it's 3.0, so it does end. The decimal point is implied right after the 3. That's technically a terminating decimal. And also you can have negative values, so like negative point, let's go with 3.5. That's a terminating decimal. It ends. And you can have negatives. In fact, fractions, mixed numbers, and decimals can be positive or negative. You could use either one. They're still rational numbers. Oops. What's the definition of a rational number? It's a number that, key words, Jensen, can be written as a fraction, where a and b are both integers and b does not equal 0. That is a decimal. That is not a fraction. Is this a rational number?
Yes.
Nick, I heard your classmates say yes, it's a rational number. But that's a decimal. A rational number is a fraction. That's okay. I'm asking a tough question. Sarah?
It can be rewritten as 4100.
Oh, that's what you meant by can be. Can you rewrite this as a fraction of integers? What would it be? Somebody? Yes.
41 over 100.
41, I'm just rewriting here. 41 over 100, right? That's 0.41. Oh, yeah, 41 hundredths. Duh. Sorry, guys, I had a mental break. But there's more to that definition. This number represents A, this number represents B, right? Are A and B both integers? Is 41, or I should say, are 41 and 100 both integers? Oh, yeah, they are. Good. But there's a third part. What's that last part? B
The denominator can't be 0?
Is this, and here's the question, guys, is this denominator 0? No. And I'm going to ask it a different way. Is this denominator not equal to 0?
Yeah.
Yeah, right? So hear it both ways. This denominator is not equal to 0. This is a rational number, therefore that is. Okay, and then we know, wait, 3? That's not a rational number. Melissa, what's a fractional version of 3? 3 over 1. But negatives, that's impossible. Negative 35 over 100, which you could reduce. Okay. There's a second type of decimal that is also... Do you have a question?
No, okay.
Yeah, okay, go ahead.
Just repeating.
Repeating decimals. Repeating. Yeah, that's the second type of rational decimal number. Okay, repeating decimals. And a couple examples here. Oh, I'll give you one. I think you guys get this. 2.333 ... What do those ... dots mean again? It keeps going on forever. And isn't it 2.3333333333333? Can you write that a better way? Is there a better way to write it? Betsy, what's the better way?
2.3 and then you put a little line in between.
Good. You put a repeating bar over the 3. That's a better way to write it. It's easier to see. Hopefully you understand. This bar right here means 3 repeats over and over again. Okay, those are rational numbers. But I'm confused about this. Let me just take this right here and see if you're confused with me. When I write this, and I'm thinking of a mixed number, can mixed numbers be turned into fractions? Can mixed numbers? Okay, and we'll get to that later. Well, I have here, would I write 2 and 3/10? Or should I write 2 and 33/100? Or should I write 2 and 333,000? Or should I write 2 and 3,333 10,000s? I'm confused right now. Okay, yes, sir?
Maybe 2 and 3/10 because the simplified version?
Okay, 2 and 3/10 is super close to the value, but it wouldn't be exact. Therefore, it wouldn't be a rational number. So how is this a rational number?
It's 2 and 1/3.
What? Oh, yeah, you're right. 2 and 1/3. Okay, there was a process we went over last year. I didn't emphasize it because we're going to do it more this year, but you can get this repeating decimal into this format right here. Okay, there is a process. It's an algebraic process. We're going through basic things, so just know repeating decimals can be turned into fractions or mixed numbers in this case. Okay, so they're all rational numbers so far. Oh, but this is a mixed number. What's the fractional version of it? Yes, ma'am?
7/3.
7/3. Oh, nice. So, yeah, 2.3 repeating is a rational number. Okay, I'm trying to give you reasons. I'm not trying to say, hey, guys, these are rational numbers because I said so. And that's what you have to go on. No, there's a reason. We'll go through that process even more. Okay, guys, okay with that? Those are your rational numbers. But what's the lesson called today? Okay, I'm going to help you out here. In my notes, I wrote the definition of an irrational number, and I wanted to give it to you. But the definition of a rational number is a number that can be written as a fraction a over b, where a and b are both integers, and b cannot be 0. Do you know what an irrational number is?
Rational number, or a number that can't be.
That's it. Irrational numbers. The whole definition of rational number, so what you already wrote, there's one thing that needs to change. You remember that underlined part that said can be? In irrational number, all you have to change it to is cannot be. That's all you have to change. It cannot be written as a fraction in the form a over b, where a and b are integers and b does not equal 0. That's an irrational number. You don't have to write that out if you get that. If you're like, oh, okay, I get that. Just say irrational numbers are not rational. And then you can just look back at your definition of rational. Whew. But if you want to write the whole definition, that's totally up to you. I'm totally okay. Just underline cannot be written, or cannot. Okay, just like with rational numbers, there are types of irrational numbers. And we'll go through these, and I'll see if you guys remember this with a little exercise. Okay, the first type. We talked already about repeating decimals, right? We talked already about terminating decimals, right? But is there any other type of decimal out there? Non-terminating and non-repeating. Decimals. Those are irrational because you cannot write them as a fraction of integers. You just can't. No matter how hard you try, it's not going to work. You can get close, but you can't get exact. So non-terminating and non-repeating decimals. Let me give you an example, and I'll explain it because there is a bit confusion here. 4.1321658 Okay, this is an example of irrational because of two things. Does it terminate? Does it end? No. Does it end? Why? ... So it doesn't terminate. It's a non-terminating decimal. But does it repeat? Is there a pattern here? Can I put a bar anywhere? No. Nope. This number right here is both non-terminating and non-repeating. This is an example of an irrational number. Okay? It has to be both of them, non-terminating and non-repeating. The second type is actually a specific example. Oh, pi, yeah. Which is the Greek letter pi. Now, have we used pi before?
Yes.
Of course we have. What do we use pi as?
3.14 or 22 over 7.
Okay, good. And this is what I'm going to put, and I need you to know what it is, why I put it that way. The approximate sign is approximately 3.14 or 22 over 7. What does approximately mean? Okay, maybe reduced, maybe, what's another word you can use, like a synonym? What?
Rounded.
Rounded, about. Pi is about these two numbers. Is pi exactly that? Exactly? No. We use it for conventional sake, and I'm going to tell you this right now. Pi, as I've talked before, is a number never repeats and never terminates. It's a number that none of us in this room, nor anyone on this planet, fully 100% knows. Yet pi is used all over the place, and that just shows God's goodness. He's giving us this big thing that we don't really understand, yet He still allows us to use it, and we use it well. But that's pi. Non-terminating, non-repeating, pi, and the third type, here's a nice square roots. I like this one. I want to see your reactions after I write it. Square roots of non-perfect squares. I guess that is kind of wordy. Write that down. I'll do my best. I'll do my best. Okay. Don't write this next example down. I'm just going to write on the board to give you a visual aid, and then I'll have you write down the next one. Okay. How many of you are at least familiar with square roots? Like you know what it looks like, the square root symbol, and you kind of get, oh yeah. I think I know what they're asking. Okay, so here, let me give you an example. The square root of, don't write this down, the square root of 25. What is the value of the square root of 25? 5. It equals 5, right? That's no problem. It's pretty good. But what's the square root of 42?
Math.
Yeah. Oh. Yeah, that's good. Yes, go ahead.
Somewhere between 6 and 7.
Get more specific. 6 and 7? Okay, cool. Yes, Davis, it is between 6 and 7, but get more specific because okay, you know, I'm going to show you next hour a calculator that tries to do it. And how many of you have siblings that have like graphing calculators? They're those really long, skinny ones that can do graphs, a lot of technical stuff. Okay, you could try to put it in the calculator, and your calculator that costs usually between $110, $130. Can't do it. Can't do it. So what do?
You can do it as fractions.
I want an
6 and
Okay, I'll come back. And it's good to try, John, but here's the thing. What type of number am I saying, to start off, what type of number am I saying that square roots of non-perfect squares are? What's the category we're talking about right now? Irrational numbers. So irrational numbers cannot be written as fractions. So as much as I try, you're going to get super close. Yeah, you're close. You're just not there exactly. And the thing is, on my calculator, I'm going to get, here's a clincher, ready? I'm going to get a non-terminating. Does that sound familiar? Non-repeating decimal. Does that look like category number 1? Okay, these values, you're going to get non-repeating, non-terminating decimal numbers. But for you guys, because we're going to make it practical, I asked you what that is. Today, by the end of the day, before you leave this class the second time, you're going to have to give me what that value is. Without a calculator, on your own, with a smile on, okay, not the smile, that part I can take out. You're going to be able to do it. And it's basically what David said. You can't get me exactly what it is. I can't, but I can get very close to it. Okay, I can get you pretty close. Okay, and it's about 6.53. And it keeps going over and over. It keeps going on and on. That's amazing. Okay, I need to explain this, especially this guy right here, because I think you get square roots, but non-perfect squares. What are you talking about? I'm going to get to that in just a moment, but I want to make sure you understand the categories of numbers. So on page 3, do you see at the very bottom it says try these? Do you guys see where it says try these?
yes.
Okay. I want you, to yourself, to read the instructions for problems 1 through 8. Just do it right now. Read the instructions. Don't do any problems. Okay, and you're going to do numbers 1 through 5. Numbers 1 through 5. Okay, so I'm going to do it with you to help you, especially the first one. Number 1. For each number, and this is the number they give me, and you can do this in your notes because you can correct them and then you can see if you got it right, leave it alone, or you can erase it, correct it, and then have that for your reference. So negative 321.11. This is how I do this problem. Let me ask this question. Is it a whole number?
No.
No. So I move on to the next category. Is it an integer? Oh, there's a debate. So an integer is a whole number or its opposite. So is it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah? Or negative 1, negative 2? Nope. It is not an integer. Is it a rational number?
Yeah.
This is where you have to look. How many of you say it's a rational? Rational. So can that be written as a fraction? Yes. Even if it's negative, it could still be written as a fraction. And basically, a good way to figure it out, can this be written as a mixed number? it would be written negative 321 and 11 hundredths, and all mixed numbers can be changed to fractions. So this is a rational number. So you're going to put rational. All right, is it irrational?
No.
What? Okay, here's a deeper question, Michael. You're a thinker, I think. You're a thinker, I think. I think. Michael, can a number be both rational and irrational at the same time? Can somebody tell me why not? You're correct. No. Why not? Can't they kind of be both, maybe? Sarah?
Because one can be written in like the form of fractions, but one can't.
Yeah, by definition, rationals can be written as fractions, irrationals cannot be written. Can something be something and also be its opposite at the same time? No. That's a law of logic. That's a law of contradiction. So if it's rational, it can't be irrational. That's my answer. So that's what I put for number 1. Number 2, I'll kind of talk this one out with you. Yes, sir?
So like, for experiments on the last one when we were looking at irrational numbers.
Yep.
We were looking kind of like at the answer and seeing if
The
that
value
was
of it.
So for these experiments, we would see if we could find an answer, and if we couldn't, then it'd be irrational, and if we could, then it'd be one of those.
That's actually the second part. Yep, that's it. Okay, number 2. I walk it through like this. Is 45 a whole number?
Yes.
Good, I put whole. Is it an integer?
Yes.
Yes, I put integer. Is it a rational number?
Yes.
Yes. Is it irrational? Automatically cannot be. Good. Number 3. Is it a whole number?
No.
Number 3. Is it a whole? No, it's not. It's a decimal. It can't be whole. Is it an integer? Ooh. Oh, okay, fine. Not an integer either. Is it rational?
No.
No.
Is it irrational?
Yes.
Why is it irrational? Somebody give me a reason. I need a reason. Michael.
Because it's repeating.
Number 3. It's non-terminating and non-repeating. It's both of those. It's irrational. Yes, ma'am?
Why did you say pi was an irrational number? Because 22 over 7 is a fraction.
Yeah, okay. I'm going to get to that because I want you to see what you guys put. So hold that question for a second. Good thought. Let's go to number 4. Is it whole?
No.
No. It's decimal. Is it an integer? No, it's not a whole number or its opposite. Is it rational?
Yes.
Oh, yeah, repeating decimals are rational. Got it. So it's not irrational. Number 5. Someone, let me give you the answer after you think of it if you haven't. You guys will be split, and you may argue with me, but that's okay. Okay, number 5 is 22 over 7, I believe. And how about this? How many of you put, you know it's not a whole number and it's not an integer. We're good with that, I hope? Rational, you put. It's rational. Okay, how many put irrational? Ooh, it's like split in half. There's only one correct answer. It can't be both. So I need an answer. Nick.
Wait, what?
Yeah, what did you put?
Well, I looked at my notes.
Uh-huh.
And it's an irrational number because
Uh-huh.
one of the options is
Okay. All right. That's okay. He gave me a good reason. He looked at his notes, and it was with irrational. Wyatt, what'd you put?
rational.
Rational. That's what he didn't say. Okay, go ahead.
Because it's approximately 22
Okay, you're okay. Look at number 5. You actually got it. Number 5. Does number 5 have any? Does number 5 say pi or show pi?
No.
Oh my
It
god.
just has
It's just a fraction. 22 over 7. That fraction is rational. If it said pi, irrational. But that's just, so remember, pi is approximately 22 over 7. Not exactly. This is exactly 22 over 7. It is rational. Does that kind of make sense? They threw you a curveball. I don't even know how to throw, but they threw it to me. Okay, and that's tough. And I hope you understand it. Get ready for more curveballs as you go through your assignment. Okay, any questions on that? You kind of get the process. You're going to be doing a lot of that. this afternoon. But you can ask questions, except what's the answer and can you do this for me? All right, let's get to the next part here. This is starting, it's kind of mixed up, but it's on page 2, and it's toward the second half. Page 2, second half. All right, squaring a number. Squaring a number. Okay. Squares are important. Oh, yeah. Squaring a number. I wrote these down. I wrote a lot more than I'm going to give to you because I don't want to overburden you with notes. But squaring a number is the same thing as multiplying a number. Yeah, did I? Oh, multiplying. Thank you. A number. And then I'm going to put by itself. It doesn't mean multiplying a number alone. It means multiplying a number by that number. By itself. Multiplying a number by itself. Okay, you're like, what are you talking about? Okay, let me give you a number. 3/8. Is that a number? Okay, what would multiplying 3/8 by itself look like? What does that mean? 3/8 times 3/8. And does anyone know what that value is?
9/64.
Yeah, you just multiply across. 9/64. Okay, nothing too deep there. Just multiply a number by itself. That is also known as squaring a number, which looks more like this. 3/8 to the second power. What's the value of this expression? It's the same thing as up there. This right here means this. Therefore, they have the same value. How many of you kind of remember squaring a number? You've either done it or like got it. Now I know what it's like. Okay, can someone give me another number? Give me an integer. Give me a small integer, just for our own sake. Yes, ma'am?
I just have
Oh, go ahead.
Would 3/8 and then like to go 4th power?
Yeah, you can have 3/8 to the 4th, to the 100th, to the 1/2. We're not getting there yet. Yeah, we're going to get there maybe at the end. Definitely algebra 2. Sorry. So give me an integer, something small, please, for my sake and yours. Caroline?
2.
Okay, 2. Thank you. 2 to the second power is equal to what? 4. Okay, give me another integer.
So,
Jensen, I don't get your question.
9.
Thank you. 9. 9 to the second power is equal to 81. Because 9 times 9 is 81. Everyone okay with that? Yes, sir. You can do negatives too. I'll put it... Well, we're getting to... I'm going to do it like this just to help you out. You can do... The opposite of 9 squared would be the opposite of 81, which is like that, right? That's how it changed. Or you could do this. Give me a negative number, negative integer. Nothing too big.
-4.
Thank you. -4 squared would be what? Ooh, that's a good... It's either -16 or 16. Which one is it? I hear 16. I hear -16. Okay, ready? This expression right here means the opposite of 9 squared. So what's 9 squared? -81, right? But you're like, Mr. A, but isn't that... Do you see these parentheses? It's saying that -4 is squared. So what's -4 times -4? Positive 16. Do you...
Parentheses changes the value.
Exactly. Those symbols mean something. Mm-hmm. Yes, ma'am.
So if it doesn't have parentheses, then it's
Like this one?
-9 times 9.
No, it'd be the opposite. You have to think of it as the opposite of 9 times 9. So what I do is, a lot of people do this. When they have this expression with no parentheses, they block the negative sign and, all right, what's 9 squared?
81.
And then they put the negative there. Yep. Can I block it here? No, you kind of have like a little barrier. So that's how people think of it. Yep.
So that means the square root of 1 is 1.
Yeah. The square root of, the square root of 1 is 1? Or the square of 1 is 1?
Yeah.
It's both, yeah.
Which means, yeah, the square root of 1.
Yep. Okay. These are tough, but guys, how many of you are okay with this right here to that? That's what we're trying to get to right now. These are other examples, and hopefully you can get those too. I'm going to give you a list of numbers that you need to memorize. I'll give you a lot of time. The first 10 minutes of the next period. Okay, no, I'll give you more time. I'm going to write these numbers down. You need to eventually memorize them. The sooner you do it, the better, but you don't have to get it right away. They are called perfect squares. Do you remember I underlined the last category of the irrational numbers? I said find the square roots of non-perfect squares. You guys see that in your notes? Square root, and you're like, what? I first have to talk about perfect squares, then I'll get to non-perfect squares, and then I'll be like, oh, now I know what you're talking about. All right, perfect squares. Let me give you the list. Okay, here it is. These are perfect squares. Perfect squares. You got to be careful too, because I don't want to skip one. Do these numbers have any meaning to you? Like, some of you kind of see, they look familiar. All of you who were here yesterday, you should have seen it yesterday. Remember those little fact sheets? Were these some of your answers? Okay. Perfect squares are this. They are numbers that are derived, or they come from a whole number times itself. So, looking at 1, John, how did I get 1? Well, what's 1 times 1? How did I get 4? What's 2 times 2? How did I get 9? 3 times 3. How did I get 25? 5 times 5. How did I get 64? 8 times 8. 100? 121? Does anyone know the next perfect square? Which is going to be 144. Anyone know the next perfect square? 169. Anyone know the next one? That's 13 times 13, by the way. You do not have to write these down unless you don't know them. Like 25. If you need to write 5 times 5, write it. That's for you. If you didn't know 169 is 13 times 13, you should probably write that down. Anyone know the next one? What's 14 times 14?
196.
Oh, 196 is correct. 15 times 15. That's all right. You'll memorize it by today. You'll memorize it soon. 225. 15 times 15. Sometimes we go to like 20 times 20, which would be 400. And then 19 times 19, 18 times 8. But I just want you to get to 15 times 15. So here, if you didn't know it, it's 15 times 15. This one was 14 times 14. And you can write that pattern there if you don't get it. You guys okay with those? How many of you think you can memorize these? You don't have to do it by today, but pretty quick. Like if you took some time, you're like, I can get these down. These numbers right here, that's what I want. Okay, so the sooner the better. So if you're like, I'm going to wait till quiz or test, good luck. And sorry that your homework takes so long. Okay, these are perfect squares because a whole number times itself is going to be that perfect square. How many of you think you know it already? Like you're just like, I got it. I believe Wyatt because he gave me 196, I think, right?
When I was little, we had to learn a song.
What? You had to learn music to that? Oh, okay, cool. What do you know what it went to?
50.
15, okay. And the more you know, the better, because what you're going to do is this. This helps me out with finding square roots of perfect squares. Ready, guys? Ready? Stay with me. you don't write this down. I'm writing it here on the board for reference. The square root of 121 is 11. Because isn't 11 times 11 121?
Yes.
That's nice. What's the square root of 100? 10. What's the square root of 225?
15.
Okay, I'm going to leave it with this. I think we're running out of time here. Here, lockers.
Square root of 228.
Oh, you. Class is dismissed. Sorry, you gotta go. I'm going to answer that after, Sarah. That's actually what the last part is.